Now we will discuss some analysis option available in Staad.pro in context of the analysis recommendation per AS4100 code. Now you can see on the screen the complete illustration has been explained, considering the fact whatever are the analysis options available in Staad.pro and whatever are the different analysis options defined in the code. Now, the AS4100 code suggests specifying the use of both first order and the second order elastic analysis. The analysis guidelines are suggested in the chapter number 4 of the AS4100 code. The objective of the structural analysis is to determine the internal forces and the moments or the design action effects. The method of structural analysis range from simple to complex depending on the structural form, and the designer must has to decide which method would be the adequate one for that task, having in mind the degree of accuracy to be required. Now, the time required to assemble the data for rigorous analysis is a consideration. Hence, simple methods are usually employed in the preliminary design. Here you can see in the screen which explains better the different analysis provision per AS4100 code and their scope of simulation in Staad.pro. Please be noted that the flowchart depicts on the screen only shows the analysis options which are available in Staad.pro. Firstly, one needs to check if the moment amplification factor if it is higher than 1.4 or not. The calculation of the moment amplification factor has been explained in the code. So if the factor is less than 1.4, then simply perform the linear elastic analysis, as the structure is a candidate for the linear elastic analysis because the structure is behaving linearly. Instead, it is instructed by the command called perform analysis. But again, if it is higher than 1.4, then as per AS4100 code, the structural behavior is a candidate of second order effect because here the second order effect is very much predominant. Now, the second order analysis can be performed either by amplifying the forces obtained in the first order elastic analysis with the moment amplification factor as specified in the code, or by performing the rigorous second order analysis. Now, the rigorous second order analysis that can be handled in Staad.pro by performing the p delta analysis or the nonlinear analysis. We will discuss this p delta analysis scope in Staad.pro very shortly. Now, for the moment amplification factor, which is shown in the right hand side of the screen in this flow chart, one has to determine the moment amplification factor. Please refer to the chapter number 4 of the code where the different rules and equations has been explained. Now, if you see the equation number 4.4.2.2, you could see that this amplification factor is the function of the ratio of the applied axial load to the buckling load. So ultimately, one has to determine the buckling capacity or the buckling factor of the member. And in order to calculate the buckling factor of the sway frame, the code AS4100 code also suggests determining the buckling factor of the entire frame structure. And this can be done by performing the frame buckling analysis in Staad.pro. We also call it as a global buckling analysis. Please refer to the chapter 4.7 in AS4100 code. The idea of performing this frame buckling analysis to get which member is the weakest one and which member is susceptible to buckle first among all the other members in the complete frame. Eventually, you have the amplification factor to magnify the result of the first order elastic analysis. So the moment magnification factor is ultimately a first order elastic analysis, which is amplified or magnified to attain or to get some result which is very close to the result of the second order analysis. So we are basically amplifying the different forces that we have obtained by performing the first order elastic analysis. However, this moment amplification factor method is a very tedious, time consuming, and it's not an exact method. Again, we are just reiterating the fact that this is a approximate method. This method is very much applicable if a designer doesn't have any computer resource and obviously he has to perform or capture the second order effect, then only he has to adopt this method, because you have to go to a lot of manual calculations and that sort of different process, like you need to refer to different charts to attain the final moment amplification factor. So this is a very tedious and very approximate approach. So our suggestion is that if you have the computer resource, then why don't you go to the second order, rigorous second order elastic analysis. And if you refer to the chapter number E of this code, you can see that they have suggested that one designer can also perform the rigorous second order analysis if you have any software or any computer resource. So considering that you are working on Staad.pro, so obviously you have the facility to perform the rigorous second order analysis by using the p delta analysis or the nonlinear analysis. So we'll discuss on p delta analysis very soon. So either you can use the moment amplification factor, or you can perform the rigorous second order analysis to get the actual design force of different different members in the structure.